Hi all, good morning. Let's start Maths, grade 11, chapter 6. Chapter name is Permutations and Combinations. Subtopic is Permutations of Distinct Objects. Learning objectives. After this session, learners will be able to derive the formula for NPR. Solve problems based on permutation when all the objects are not distinct. Derivation of the formula for NPR. NPR is equals to n factorial divided by n minus r factorial 0 less than or equal to r less than or equal to n. We know that NPR is equals to n into n minus 1 to n minus 2 and so on n minus r plus 1. Let us multiply both numerator and denominator by n minus r to n minus r minus 1 so on till 1. So we get that NPR is equals to n into n minus 1 into n minus 2 and so on till 3 into 2 into 1 divided by n minus r into n minus r minus 1 into 3 into 2 into 1. By observing this numerator, we can write it as n factorial and the denominator we can write it as n minus r factorial. Therefore, NPR is equals to n factorial divided by n minus r factorial, where 0 less than r less than or equal to n. The number of permutations of n different objects taken r at a time, where repetition is allowed, is n power r. Permutations when all the objects are not distinct objects. The number of permutations of n objects where p objects are the same kind and rest are different is equals to n factorial divided by p factorial. The number of permutations of n objects where p1 objects are of one kind and p2 objects of second kind, pk are of k kind, then the rest. If any are of this different kind is there, then we'll let it as n factorial divided by p1 factorial to p2 factorial into p2 3 factorial so on to pk factorial. Let us start exercise 6.3 question number 1. How many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? Solution. The 3-digit number to be formed using the digits 1 to 9 without repeating the digits. It will be having hundreds place, tens place and units place. In the last exercise we have observed, in the hundreds place we can fit 1 to 9 because there is no 0 is involved, so all 9 options we can use. The tens place we have to exclude 100, whichever number we have used in the 100 place, so there will be only 8 options. Now coming to the units place, we have to exclude the 2 options which we have already used in the hundreds place and tens place, there will be 7 options. This is the old method. Now let us use the formula. We know that n is equals to 9 and r is equals to 3 because n is 1 to 9 we are using, so number is 9 here. But how many digits number we are forming? 3. So r is equals to 3. We know NPR is equals to n factorial divided by n minus r factorial. So let us substitute. In place of n as a 9 and r is a 3. So then we will get as 9p3, that is 9 as a permutation in this one. 9p3 is equals to 9 factorial divided by 9 minus 3 factorial, that is 9 factorial divided by 6 factorial. So we can write 9 factorial as 9 into 8 into 7 into 6 factorial divided by 6 factorial. We can cancel 6 factorial here. So we are going to get the value as 9 into 8 into 7, that is 504. Therefore, number of 3-digit numbers can be formed is equals to 504. Let us solve 2. How many 4-digit numbers are there with no digit repeated? Solution. The 4-digit number to be formed without repeating the digits. So here, in the thousands place, we can have 9 options because we need to exclude 0 here. In the hundreds place, we can include 0, but we have to exclude this option. So in the hundred place, we will be having 9 options, here including 0. The tens place, we have to exclude the 2 options which we have used here. So it will be 8 options. In the units place, 7 options. Therefore, this is a traditional method. Now let us verify using the formula. Now here n is equals to 10 because 0 to 9. This number of digits is 10 and the r is equals to 4. NPR is equals to n factorial divided by n minus r factorial. This is 10p4, that is 10 factorial divided by 10 minus 4 factorial. That is 10 into 9 into 8 into 7 into 6 factorial by 6 factorial. That is 5040. But here number of digits with 0 as a thousands place, this is we have to consider because we have to exclude this 0 as a thousands place. Then it will become the 3-digit only. So that is 9p3. 9 factorial divided by 9 minus 3 factorial. That is 9 factorial by 6 factorial. That is 9 into 8 into 7, that is 504. So from this 5040, we have to remove this one. Therefore, number of 4-digit numbers formed without repeating the digits is equal to 5040 minus 504, that is 4536. Let us solve question number 3. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated? Here we should read this 3-digit even number. Among the given digits, how many even numbers are there? 3. So in the units digit, it's a constraint to the only 3 digits. Solution. The 3-digit number is even. So possible digits for units place is 2, 4, 6. So let us have this. 3 digits place will be having hundreds place, tens place and units place. We know clearly that units place is having the 3 options. So we'll be using the 3 options. The tens place, the remaining among the 6 digits, one will be used in the unit place. So that is the 2, 4, 6 only will be using as it is an even number. The remaining 5 options will be using the tens place. The 4 options for the hundreds place, that is 4 into 5 into 6. That is 60 will come. Now let us use this. In the units place we have 3 options, 2, 4, 6, 2 digits to be selected among 5 digits. This is this by using the formula. So let us use n as a 5 now and r as a 2. Therefore, NPR you know that n factorial divided by n minus r factorial, that is 5p2, that is 5 factorial divided by 5 minus 2 factorial, that is 5 into 4 into 3 factorial divided by 3 factorial, 3 factorial, 3 factorial get cancelled. So 5 4 is 20. So this is if units places is a 2 is selected. Okay. Then if units places 4 is selected, also we'll get the 20 as the answer. If units place is 6 is selected, 20. So 20 plus 20 plus 20 is 60. Therefore, number of 3-digit even number formed using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated is 20 into 3, that is 60. If you want to verify, this is you can verify 4 5 is 20, 23 is 60. So this both the answers are matching. Let us solve question number 4. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated. How many of these will be even? Solution. The 4-digit number to be formed using the digits 1, 2, 3, 4, 5. Here, in this units place will be having 5 options. We are coming in this from this way. In the tens place 4 options, hundreds place 3 options, thousands place 2 options. Okay. Then this we can by multiplying this one 4 5 is 20, 20 into 3 60, 60 into 20 is 120 is the answer. But let us do this by using the formula. Here n is equals to 5 and r is equals to 4 because we need to form the 4-digit number. So r should be 4. So NPR is equals to n factorial divided by n minus r factorial, that is 5p4. 5 factorial divided by 5 minus 4 factorial, that is 5 factorial is 120. Therefore, this is 120. If you want to verify, 2 3 is 6, 6 4 is 24, 24 into 5 is 120. So both the answers are right. Now, number of 4-digit numbers formed using the digits 1, 2, 3, 4, 5 if no digit is repeated is 120. This is the answer. The second subsection is how many of these will be even. So whenever it will be even, units place should be only 2 or 4 options will be there. Okay. Therefore, remaining this digits will be left out. 4 digits will be left out. So that in that one we need to select as a 1 digit for the tens place, 1 digit for the 100 place, 1 digit for 1000 place. That is n is equal to 4 and r is equal to 3. That is 4p3. Therefore, 4 factorial divided by 4 minus 3 factorial, that is 4 factorial, that is 24. Now, units place let us keep the 2. So we have the option for the 24. If we keep the units digit as a 4, then we'll get the 24. Therefore, how many of this will be even is 24 plus 24 is 48. So number of 4-digit even numbers formed using the digits 1, 2, 3, 4, 5 if no digit is repeated is 24 into 2, that is 28, 48. Let us solve exercise 6.3 question number 5. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman assuming one person cannot hold more than one position? Solution. Number of persons in a committee generally we will consider as n, that is equal to 8. The number of people to be chosen from the committee is equal to, we will make it as r2. So now we know NPR formula. NPR is equal to n factorial divided by n minus r factorial. Let us substitute n as a 8 and r as a 2. Therefore, 8p2 is equals to 8 factorial divided by 8 minus 2 factorial. That is 8 factorial divided by 6 factorial. We can write 8 factorial as a 8 into 7 into 6 factorial divided by 6 factorial. Let us cancel 6 factorial and 6 factorial. And we are going to get this value as 56. Therefore, number of ways to choose a chairman and a vice chairman is equals to 56 ways. Let us solve question number 6. Find n if n minus 1 p3 is to np4 is equals to 1 is to 9. Let us solve this. Given n minus 1 p3 is to np4 is equals to 1 is to 9. We know that npr is equal to n factorial divided by n minus r factorial. Now, for n minus 1 p3, which is n minus 1 factorial divided by n minus 1 minus of 3 is 2. N factorial divided by n minus 4 factorial is equals to 1 is to 9. Here, n minus 1 factorial divided by n minus 4 factorial is to n factorial divided by n minus 4 factorial is equals to 1 is to 9. Let us cancel n minus 4 factorial and n minus factorial. So, we are going to get n minus 1 factorial is to n factorial. That is equals to 1 by 9. N minus 1 factorial will keep as it is, and denominator we can write it as n into n minus 1 factorial. That is equals to 1 by 9. Now we can cancel n minus 1 factorial and n minus 1 factorial. So 1 by n is equals to 1 by 9. This implies n is equals to 9. Therefore, n is equals to 9. Let us solve question number 7. Find r if 5pr is equals to 2 into 6p into p of r minus 1. Second one, 5pr is equals to 6 into pr minus 1. Solution. Given 5pr is equals to 2 into 6pr minus 1, we know that npr is equals to n factorial divided by n minus r factorial. So 5pr we can write it as a 5 factorial divided by 5 minus r factorial is equals to 2 into 6 factorial divided by 6 minus r minus 1 factorial. That is 5 factorial divided by 5 minus r factorial, 2 into 6 into 5 factorial divided by here 6 minus of minus 1 is plus 1. So that's 6 plus 1 is 7 minus r factorial. Now we can cancel 5 factorial in the numerator, and this 5 minus r we can cancel. So we are going to here, we can write it as 5 factorial divided by 5 minus r factorial, 2 into 6 into 5 minus factorial divided by 7 minus r, 6 minus r, 5 minus r factorial. We can cancel these 5 minus r, 5 minus and 5 factorial. So we are going to get as 1 is equals to 12 divided by 7 minus r into 6 minus r. Now let us transpose here. We are going to get 7 minus r into 6 minus r is equals to 4 into 3, because if we observe these are the consecutive numbers. So 12 we can write it as a 4 into 3. Now if we compare this one, as this one is greater than the 1, this 4 is greater than 3 here, it implies the difference between 4 and 3 is 1, plus difference between 7 minus r and 6 minus r is 1. So we can ensure that 7 minus r is equals to 4 and 6 minus r is equals to 3. Therefore, 7 minus r is equals to 4 and 6 minus r is equals to 3. That implies r is equals to 3. Let us solve subsection 2. 5pr is equals to 6 into pr minus 1. That is 5 factorial divided by 5 minus r factorial is equals to 6 factorial divided by 6 minus r minus 1 factorial. That is 5 factorial divided by 5 minus r factorial is equals to 6 into 5 factorial divided by 7 minus r factorial. Here 6 factorial, we write 6 into 5 factorial, 5 minus r factorial, 7 minus r into 6 minus r into 5 minus r factorial. Let us cancel 5 minus r factorial, 5 minus r factorial and 5 factorial, 5 factorial. So we'll be going to get 1 is equals to 6 divided by 7 minus r into 6 minus r. Let us transpose this to here. Then we are going to get 7 minus r into 6 minus r is, you can write it as 3 into 2. Now comparing 7 minus r is equals to 3 and 6 minus r is equals to 2. We'll get r value as here 4. So the only difference here, this one is, for the first one we are getting r as a 3, the second one we are getting as a r as a 4. Because here if we observe, we are getting 4 into 3, but here we are getting this 3 into 2. Let us solve question number 8. How many words with or without repeating the meaning can be formed using all the letters of the word equation, using each letter exactly once? Solution. In the word equation there are 8 letters. Okay. So we know that npr is equal to n factorial divided by n minus r factorial. Here n is 8 and r is also 8. Therefore 8p8 is equals to 8 factorial divided by 8 minus 8 factorial. That is 8 factorial divided by 0 factorial. But 0 substitute 0 factorial is 1. So 8 factorial is equals to 8 into 7 into 6 into 5 into 4 into 3 into 1. That is 40,320. Therefore, number of different words that can be formed using the letter in equation by using each letter once is equals to 40,320. Let us solve question number 9. How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated? First one, 4 letters are used at a time. Second one, all letters are used at a time. Third one, all letters are used but first letter is vowel. Solution. 4 letters are used at a time. So we can use this one. N is equals to 6, R is equals to 4, because in Monday there are 6 letters are there. So now our questions 4 letters we need to use at a time. So R is equals to 4. Therefore 6P4 is equals to 6 factorial divided by 6 minus 4 factorial. That is 6 factorial divided by 2 factorial. That is 6 into 5 into 4 into 3. That is 360. Therefore, number of words possible with 4 letters at a time is equals to 360. Second one, all letters are used at a time. So that is here, N is equals to 6, R is equals to 6. Therefore, 6P6, that is 6 factorial. 6 minus 6 factorial. That is 6 into 5 into 4 into 3 into 2 into 1. That is 720. So number of words possible with all letters at a time is equals to 720. Vowels. So considering the first letter as a vowel, two options are possible. That is A or O. So N is equals to 5, R is equals to 5 with the remaining we have to use. Therefore 5P5 is equals to 5 factorial divided by 5 minus 5 factorial. That is 5 factorial. 5, 4, 3, 2, 1. Now that is equals to 120. That is only for the 5 letters we use. But the first letter is vowel. No? If the first letter is A, we have be having the 120 option. If the first letter is a O, then it will be 120 option. So total will be 240. Therefore, number of words possible with all letters, but first letter is a vowel is equals to 240. Let us solve question number 10. In how many of the distinct permutation of the letters in Mississippi do the 4 I's not come together? Solution. In the word Mississippi, there are 11 letters and there are 4 I's, 4 S and 2 P's and 1 M. So the number of permutations of n objects where P1 is this one kind and P2 is of one kind and Pk of one kind, we know the formula as n factorial divided by P1 factorial, P2 factorial and P3 so on Pk factorial. Okay. So therefore 4 I's are there, 4 S are there, 2 P's are there. So P1 is equals to 4, P2 is equals to 4, P3 is equals to 2. So total number of permutations is equals to, here n is equals to 11, right? So therefore 11 factorial divided by P1 factorial is 4 factorial, P2 factorial is 4 factorial, P3 factorial is 2 factorial. That is 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial, 4 into 3 into 2 into 1 into 2 into 1. Okay. So we are cancelling 4 factorial, 4 factorial and we are writing this remaining. After cancelling we are going to get 34,650. So now here 4 I's should not come together. So I. Okay. So 4 I's should make it this one. So total number of permutations the 4 I's together is 8 factorial divided by 4 factorial into 2 factorial. Because if we remove this I, so we will be having this 1, 2, 3, 4, 5, 6, 7 and 4 I's together 1. So it will be 8 factorial divided by. Now here as S is repeating 4 times, so this is 4 factorial. And P is repeating 2 times, 2 factorial. That is 840. Therefore, number of distinct permutations of the letters Mississippi with the 4 I's together is equals to total number of permutations plus total permutation with I's together. That is 34,650 minus 840. That is equals to 33,810. Therefore, number of distinct permutations of the letters in Mississippi with the 4 I's together is equals to 33,810. Let us solve question number 11. In how many ways can the letter of the word permutation be arranged if the word starts with P and ends with this? Yes, vowels are together and there are always 4 letters between P and S. Solution. Word start with the P and end with S. Okay, so here this P and S are stay positions are confirmed. Okay, so the remaining we can write it as is n as a 10 because as P and S are fixed positions, now it will be R is equals to 2, we'll make it as. Therefore, total number of arrangements with P and S fixed is equals to 10 factorial divided by 2 factorial. That is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 because 2 factorial we are cancelling 2 and 2. Therefore, that is it will come as is here 18 lakhs 14,400. Let us solve. Vowels are together. Vowels are together means here E, U, A, I, O are there. So 5 vowels are there. So total permutations of these 5 vowels we can write as a 5p5. That is 5 factorial divided by 5 minus 5 factorial. That is equals to 120. But total number of remaining arrangements is here n is equals to 8 and p is equals to 2 because here p is equal to because here npr. Okay. Here this p is repeating twice. So we are making this as 2. Therefore 8 factorial divided by 2 factorial 20,160 base. Therefore total number of arrangements this is equals to 120 into 20,160. That is 24 lakhs 19,200. Let us solve subsection 3. There are always 4 letters between P and S. So here the generally permutations is there. If P and S there will be like 4 letters means if this is in this first portion, then second, third, fourth, fifth portion there should be a gap. So that's why if this is P is in the first portion, S should be in the sixth portion. If P is in the second portion, S should be in the seventh portion. If P is in the third portion, S should be in the 8th portion. Similarly, like if P is in 7th portion and S is in the 12th portion. And vice versa also. If S is in the first portion, P should be in the 6th portion like that. So total number of ways arranging P and S such that there are 4 letters between P and S is equals to 2 into 7 because this is 7 ways. And this reversing this one. Position of S as a first and second. So we will be getting this second 7. So 2 into 7 is 14. There are 14 ways. So total number of arrangements generally this will be 10 factorial divided by 2 factorial because only P and S are here. Therefore 10 factorial divided by 2 factorial. Here this 2 is repeating as T is repeating here. Therefore we are going to get as 14 into 18 lakhs is 14,400. That is here we are going to get as 2 crores to 4 lakhs in this 1,600. Thank you.